What's going on, everybody? Oh, okay. What's going on, everybody? The Traveling Yam here again, and today I wanted to talk about Conflux. Initially, I was going to make a video examining MoonSwap and its zero gas fees, but I decided it would be better to build a foundational understanding of the blockchain that supports MoonSwap, examining how and why zero gas fees are even possible. So before I go any further, I'm just going to talk quickly about some of the resources that I use to gather my information. So I used the white paper from the Conflux website. You can see that right here. There was also a presentation that I used to get some information from that you can find right here. It's just under developers, and then here's a presentation. And lastly, I used a video series from Conflux themselves explaining quite in depth, to be perfectly honest. There's like maybe an hour or so here of information in terms of what the graph tree is, how it works, and it's pretty technical, but it's a simplified version of what Conflux is. It's technical and it's not at the same time. So shout out to Peter and Confi, I think is what this guy called himself. Super educational, super awesome. If you were feeling a little lazy and you didn't want to go through the hassle of checking out all these different resources, you can just stay here. I'll be able to provide you with a pretty simplified or condensed version of what all of these resources have to offer in terms of how, like the explaining of Conflux. And lastly, I'm going to be going over two of the main protocols that were touched on in the YouTube video and kind of how they work, those being TreeGraph and Gast. So also before we start, I just want to say that I am not a financial advisor. This is for entertainment purposes only. You should do your own research. Okay, now with that out of the way, I just want to start out by saying that I've tried to film this video. I'll just go right to the top. I just want to start out by saying that I've tried to film this. I've tried to film this video like 20 times, but the sheer amount of depth that I would need in order to properly explain everything is astounding. It's actually quite astonishing how much information they can pack into one of these white paper pieces. So with that in mind, this is going to be a quick and dirty version of what Conflux is and the problems that it's trying to solve, which are currently plaguing Bitcoin and Ethereum. So, yeah, so like a lot of the stuff was highlighted when I did my first pass, and it's just their notice saying that this is not legal advice or whatever. But I'm just going to do a summary, because if I don't, it'll take me too long to kind of nitpick through all of these points, so I'm going to pick major points. So initially I was going to read you much of the definitions of what Conflux is, but for the sake of simplicity, I'm going to be paraphrasing. Like, this definition is like proof of work blockchain network that allows the parallel processing of blah blah blah. So first thing that we need to ask is what exactly Conflux is trying to solve. Now, the two major problems that Conflux is trying to solve is, one, by allowing parallel processing of blocks and transactions, Conflux is able to both increase the TPS. Now, what's TPS? TPS is transactions per second, and drastically decrease the gas fees associated with each transaction. So the main reason that gas fees are a thing is because, one, it depends on the complexity of the transaction or the thing that you're trying to do on the blockchain, but two, it also depends on the amount of time that you spend on the blockchain. And so as I go further along here, I'll be able to show you why Bitcoin and Ethereum are not efficient, and why gas fees are high is mainly because of how much time each transaction is taking spent on the blockchain. And the second major problem that Conflux is trying to solve or overcome is a problem associated with leaving unpaired smart contracts on the blockchain itself, which results in both a burden to the community as well as a slowdown of the network as a whole. So that's kind of mentioned right here. I think, yeah, see, unpaired smart contracts, occurrence, blah 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 blah. So the two main things, I even wrote a little note here, but the two main things that they're trying to solve is decrease transaction times or throughput rate, or transactions per second, effectively decreasing the amount of gas fees, because if you can decrease the amount of time it takes for a transaction to be on the network, then it effectively decreases the amount of gas that you have to pay. The second thing is it's trying to free up space for contracts that are just left, in this case on Ethereum's blockchain, and if they don't get removed or nothing ever happens to them and they're just left on the blockchain, it can ultimately slow down the overall network itself. So let's start by first trying to tackle why parallel processing of blocks will reduce gas fees and increase transaction times. In order to do that, we need to look at what's going on with BlockFi and Ethereum. So I'm going to scroll down to the part of the paper where they're talking about Bitcoin specifically. So currently Bitcoin and Ethereum are both using what is called the longest chain rule in order to determine the parent chain or pivot chain. There's more on this later, but just keep in mind that the longest chain rule is a limitation. So Bitcoin is currently capable of undergoing 7 transactions per second, and Ethereum on the other hand is capable of undergoing around 30 to 40 transactions per second. Now this difference is mainly because in the paper itself, this is just more about what's bad about Bitcoin. Again, like I made notes about some of this stuff, but there's so much here that I decided to just condense it down to make it as simple as possible. So here it says 40 transactions per second, whereas on the website itself it says that that Ethereum is capable of 30 transactions per second. Now you might be asking yourself, Yam, why are these numbers important? Why, thank you, random person who I hope is subscribed and has hit the like button. These are important because in order for global adoption to take place, these blockchains would need to try to meet something closer to, let's say, as mentioned in the paper here, the Payments Canada processing, which is around 650 transactions per second, or Visa's transactions per second, which is around 3,000. Now going back to the question about why the longest chain rule is limiting. For that, we need to look at the presentation slides associated with Bitcoin, and that can be found right here. What the longest chain rule is getting at is that if on the blockchain there is a fork, the longest chain rule dictates that the fork with the longest chain will be kept and the other will be discarded. Now this is beneficial because there shouldn't be conflicting data points, but this is harmful because this can cause slowdowns to an already slow blockchain, only capable of producing, I think, 1 block every 10 minutes is what the paper suggests. Let's see, it's right, it's at the top here. Yeah, see, there's 1 block that's produced, yeah, so the block formation time of 10 minutes for every block, essentially. This was improved upon by Ethereum, hence the whole 30 transactions per second instead of 7. But as you can see, this is nowhere near what it needs to be. So this is where Conflux comes into play. Now the simple solution, you might be asking yourself, and they kind of forecasted that you might be asking this on their website, is why don't you just increase the number of blocks? Like, wouldn't that just speed up the transactions? Well, that is actually part of the solution. It's just not the whole truth. What Conflux has decided to do is create what's called a tree graph, and that is seen right here. I know it seems complicated right now, but hopefully after I explain it to you, you'll be able to better understand it. Again, keep in mind that again, this is an oversimplification, so just keep that in mind. A tree graph is essentially what you're looking at now. It consists of a parent chain, which is all these blocks running down the middle here, and a series of reference chains, which is all of these little dashed lines. These are all reference chains. All of these blocks are capable of increasing the throughput rate, which again, just remember that means transactions per second, and will result in transactions spending less time on the blockchain, effectively decreasing the transactions per second. So what the structure here is it's called a tree graph. Now the tree graph, the technical term, actually tree graph only represents the parent chains, so all of the blocks that are associated with a parent chain. And there's something called, I have it here, there's something called a DAG, which is a direct acyclic graph, and that represents the entire structure itself. Now what the website is suggesting is that the current Conflux network is capable of producing over 3,000 transactions per second. Now remember that in the original diagram, Visa was able to produce around 3,000 transactions per second. Now what this is basically saying is that because of Conflux's new innovative design in terms of how they've set up the blockchain to not only allow for more than one chain to be present, in addition to the parent chain and all the reference chains, it greatly increases the rate of transactions. And what that means is that it will greatly reduce the overall gas fees, because again, as I said earlier, the less time spent on the chain ultimately results in lower gas fees because you're taking less time occupying the space which could be needed for other transactions. This is good because less time spent on the chain effectively means that gas fees will decrease dramatically. Does that make sense? The less time it takes for your transaction to take place, the less it will cost overall. Lastly, I just want to quickly touch upon how they are. I think it's a little further down, somewhere here. Somewhere down here. Anyways, it's somewhere around here. I just wanted to quickly touch on how they can reduce the number of smart contracts occupying space on the blockchain. Now, this is by associating a fee with storing the contract while it's on the chain. That's basically how they're gonna. Yeah, see here. Conflux requires users to bond native tokens in order to store or occupy the space, which implicitly creates a disincentive to occupy space unnecessarily. So by decreasing the amount of smart contracts that are just left sitting on the chain, this ultimately declutters the network and allows the network to run more efficiently. So that's basically everything that's basically everything in a nutshell. The next video I'm going to be exploring MoonSwap and how it's capable of having zero gas fees. So the short answer to that is that the gas fees on MoonSwap are zero. They claim or they state that they're capable of having zero gas fees because the Conflux network or the Conflux blockchain reduces the amount, it reduces the time that transactions spend on the blockchain, effectively reducing the gas fees to such a small amount. MoonSwap basically sponsors, it's called a sponsorship program, they basically sponsor whatever little gas fees are left. So they basically pay for them themselves. Now you might be asking, well, who pays for the gas fees? Well, it's the miners. The miners who are mining MoonSwap or Conflux are effectively paying for the gas fees. Now, again, that's oversimplified. There is an article by Medium. Let me see if I can find it. There's basically an article, Medium, Conflux, gas. So I have a potato. Fees. Sponsored. Yeah, sponsorship. Sponsored. I wasn't. Here. So there's a sponsorship mechanism that Conflux puts in place in order to allow zero gas fees on MoonSwap. Again, I'll get into more of the nitty-gritty on this. Again, I'm sorry, I have a potato for a computer, that's why it's taking so long to load. I'll get more into the nitty-gritty in terms of how this works in the next video, which actually will be exploring MoonSwap, the wallet that you will need for MoonSwap, etc., etc. But as of right now, that's basically everything. If you have any questions, please leave them in the links down below. Peace!